Hello everyone, so we're going to be doing a little bit more assembly language programming on the Atari 800 XL with the 6502 CPU. In the previous videos we kind of figured out how to make a simple program, and today we're going to learn how to run it. So if you want to follow that, the link's in the description. So yeah, we are using the Atari Roots book. It was written in the 1980s or something, or just following through it and learning all about programming on the Atari 800 or 8-bit in general. Um, so the link for that book, if you want to follow along, is also in the description. We're using the Altera emulator because I don't have a real Atari. I would love one, but it'd be hard, like with the screen and everything like that. But yeah, so I'm using the Altera emulator and we're using the Max65 assembler. So that's what we're using, and we'll continue right here. All right, chapter 5. Um, yeah, so I wanted to mention I made a little cheat sheet that is on GitHub. I will link it in the description based on things that I picked up from the last chapter that seemed important. So stuff like you need a directive to say where you want to put the program in memory and the end directive to tell it to end the program. Comments or semicolons that can show up either in the label field or the comment field. And then stuff about our compiler. If you're using Atari Assembler, oops, I typed this in wrong. I'll edit it later. It's we type in bsave on the Mac65, but Atari would type save. And on the Mac65, you need a .opt obj directive to actually put the program into memory after you assemble. Otherwise, it won't be in memory. And just a few of the commands that we use: new to clear memory, list to show the program, list with the drive and the file name to save the source code into the drive, and enter is to load it. So these are like kind of like opposites of each other, right? So list actually saves it and enter loads the source code. So yeah, let's do that. So right now, if I type in list, you see nothing. And then I'm going to load the program. I think it was addnrs dot source, right? Yeah. So you see that little one that loads, that shows the drive was spinning. And then we do list, and here is our code. This was the directives for the Mac65 to load into memory. And here is the .end to end it. Bsave saves the binary like object file in the memory, and you have to kind of remember, like, now I think I can run assembler, right? Yeah. And then when you want to save it, you just look at these like memory locations, I think. So this, we start in 600 and ended in 609. These are all hexadecimal. So that's where you put in like bsave file, and then you put the two addresses beginning and end here. So the bload is basically loading the the object code we saved, which would be addnrs.obj, and that worked. The only tricky opcode that I remember was CLD, like it's not like clear, carry, load accumulator, add with carry, add accumulator with carry, store in the accumulator. No, store the accumulator in this address and return subroutine, but CLD, I could remember it, but I don't. So clear decimal mode. So I wrote it down mostly for myself, and it means that we're not doing binary coded decimal numbers. We covered that in like 2 videos ago, probably. Anyway, so that's what I wrote here. If you want to check this out, it'll be in the description also. Or yeah, let me know if you want to add to it. So we will, and then here's the actual book we're following, and we are going to, oh yeah, we're going to chapter 5, but I will be using the PDF. So we go here just because it looks a little bit more authentic. Chapter 5, Running an Assembly Language Program. There are several ways to execute a machine language program on an Atari computer system. For example, you can run a machine language program by using a special debugging command, the G command, provided by both Mac65 assembler and Atari assembler. Running the program using the Atari disk operating system, DOS, or if you have a Mac65 assembler, the OSA plus operating system. What is that? Have no idea what that is. Run using the autorun.sys utility of Atari DOS, or a startup.exe file if you're using the OSA plus operating system. Calling your machine language program from a basic program. Wow, there's so many ways. That's kind of insane. I feel like I should write this down, no? Like, where's my little thing? Here we go. Let me write this down here. What was the error I had earlier? Assembler, right? Okay, so now we're gonna do how to start. And it was like, we have an option of using G command, G debugger command, and then we have an option to use running the program using Atari disk operating system. Atari DOS or OSA plus OS. We'll just say like this. I don't even know what that means. Autorun.sys of Atari DOS or startup.exe for OSA plus. All right. And calling from basic. Static. How to run, right? How to execute program. All right, so we have, at least we have that now, right? All right, so where were we? Language program. In this chapter, we'll cover the first three of these methods of running machine language programs. Okay, so we're not going to cover the basic. The fourth technique, calling assembly language programs from basic, will be covered in chapter 8. Oh my god, we gotta wait like, what is this, chapter 5 or 4? Gotta wait a while. First, we'll discuss the technique for running a program with the G command offered by the Mac65 assembler, your assembler's built-in monitor. To use the G command, you'll need the help of a handy tool that's provided free with both the Mac65 assembler and Atari assembler editor cartridge. That tool is called a debugging utility. If you've just finished chapter 4 and still have your computer turned on, you can start using your assembler's debugging facility in just a few moments, as soon as readers who've turned their computers off between chapters have a chance to get their machines back into action again. If you've turned off your computers since the end of chapter 4, please get it up and running again. You will need your data disk in place and your assembler turned on. When the edit prompt appears, you can load the source code. It's basically what we did. It's like, you know, I just reset the computer, right? So you can just see all of that. I think we can skip all of this. Yeah, we have this opt obj, right? Yep, opt obj in line 5. And that means that it will be loaded in computer's memory as it is assembled. Once line 5 is either in your program or out of it, depending on what kind of assembler you have you can assemble it by typing ASM, right? We did that already. Your assembler will present you with an object code listing of the program. Yes, we've done that. Then you can use the debugging facility built in your Mac 65 or Atari assembler to debug your program and save it on a disk in its final form. The debugging facilities of the Mac 65 assembler and the Atari assembler are quite similar, but there are a few differences. Using the Mac 65 debugger, the debugger built into the Mac 65 assembler is called Bug65. That's a cute name. I wonder what it stands for. It's like something assembler cartridge, maybe 65K. I'm not sure. To use it, you must first make sure that your add numbers source code has been properly assembled using the opt-obj directive. Yeah, we did that. Then, while your assembler is in its edit mode, type the command cp. That will return you to the assembler's OSA plus operating system. I guess we have a different operating system, huh? All right, so we type in, ooh, I'm so sorry. All right, so we can type in cp. Holy cow. Disk Operating System 2 version 2.5 Atari Corp. I don't think I'm using the OSA thing. This feels like the Atari one, doesn't it? Alright, we might have a problem. Now in the response to the OSA plus prompt D1, type bug65. I don't have bug65. I don't think that's gonna work. Yeah, that's not right. So how do we go back? This isn't it. Maybe just type bug, not debug. Ay. Let's go back to this. We're in Mac 65. And we don't have, we don't have it. So then we have to load it. .source. Oh, it was, oops, that actually saved it. I just deleted my program. I should have typed enter. I've just really screwed myself up. Holy cow. Maybe Atari doesn't actually save the disk drive. I think I'm screwed. I think I'm screwed. This is I'm probably not the first person to have ever done this, right? Holy cow. I didn't make a backup of this either. Does that mean I just have to type it again? Guys, I'm so sorry. But big lesson learned. Make backups. Maybe we should write that down. We should write that down. Did you see my face that I look like? Make backups of your drive. Do not type in list instead of enter by accident. Oh my god. That was terrible. You know, people say that you learn from making really cringe mistakes. And that was like a really cringe mistake, so there's a good chance I won't ever make that mistake again. Oh my god, that was terrible, really terrible. Alright, so let's just do this again. 40. This will be good practice because I should find the program where it was actually written the first time. We read a lot, didn't we? Yeah, this is it. 40, and we need one space for, this is the label, and I think the directive is another space in. So we type 0600, then 50 has nothing, then we have 60 CLD. This is the clear decimal flag, and that, oh, I did it in the wrong place, didn't I? Yeah, this has to be like here. And then 70 is, this is the add NRS label, and then we add CLC at the same time. Clear carry. Then 80 is load accumulator with the value 2. 90 is add with carry, add accumulator value with carry. So it's going to add whatever is an accumulator and the number 2. Then 100 is store it into address CB, the result, store the accumulator. And then we have return subroutine. And then we have end program. All right, that looks right, I think. We run assembler. Seems to be the same thing. We need the 05, which is like dot option. Oh, it needs 2 spaces, right? Dot option obj, I think. And that will put it in memory. Yeah, there we go. Well, I don't know. I think that's right. And now we will save this, enter, right? And list is to list is to save, enter is to load. This is so dangerous. addnrs dot source, right? Enter. No, list. Yeah, that's correct. Okay, I'm gonna save it twice because NRS2. Just like make a second copy just in case. And then we can also do a B save. Oh, the B save we don't have to rewrite because we already saved it. Alright, so here we go. Here's our code. I think that is right. It didn't give us any errors. Error 0. That didn't take too long, right? Alright, so now we go back down to wherever we were. Okay, where were we? Yeah, here we were. And then we were having problems with DOS, which is kind of strange, right? I don't know why we're having problems with DOS. Alright, we'll return you to the OSA prompt. So we typed in bug65 and that was not happy. Let's just try it one more time. Oh, first type in CP. And this brought us to here, and that can't do anything. That's not useful for anything. Because we can't, like, do anything from here. Now, if I want to load the file, let's not screw up again. List loads it. Is that right? List saves it. Enter loads it. I need to, like, have this somewhere. Yeah, I have some kind of learning disability. And add enter source. Okay, so we're back here. So CP didn't work. So what do we think we need to do? Type bug65 using the Atari. Now, this can't be right, right? Like, no. Damn it. Maybe. So what does it say? B60. It says CP, then type bug65. Maybe it's bug65 directly here. No. All right, so we have a problem. What is OS/A plus operating system? Do you think it's because I put the DOS files on this disk drive? Let's look at the browser. And we can like figure out what is OS/A plus operating system. Okay, this is not what I want. But that is what it said, right? Yeah, OS/A plus. Max 65 OS. Oh, here's something. System software. An operating system for Atari computers. Optimized software. So these guys make Max 65, I think, right? But what is it? Well, maybe we can glance at this. Console processor CP booting up. OS/A was originally an accident brought by the fact that we developed Atari's DOS and Atari's BASIC on an Apple II computer. What? We wrote our own simple CIO, central input-output system. From there, it was only logical we install a console processor similar to that of Digital Research's CPM. Although both versions of OS/A Plus for the Atari will run nicely in 32K, it isn't realistic to use less than 40 or 48K. All right, getting started. Anxious to try. Well, what is it even? Let's just keep like taking a quick look. OS/A Plus master disk. So maybe I need like this OS/A disk. We're in Atari Mania OS/A Plus. I wish there was some way for us to like, maybe we just look in Atari Mania like, can we do a search here? Doesn't look like it. How is that possible? Atari Mania OS/A Plus. Is this what we just looked at? This is something. PDF version, DOS, OS/A Plus. Welcome to OS/A Plus. Download, dump. What do you think this is, though? OS/A Plus zip. Oh, they are disk files. Interesting. So maybe we grab that and put it in our Atari folder. Oops, my light's just about to fall out or something. Atari, now we have OSA Plus. All right. And now what we can try to do is load our drive. Let me switch to desktop so you can see that. We'll do attach disk here, I guess. Modified. Oh, how do I save it again? I forget. Disk drives. Maybe it's like save disk. All right. So that's there. Now we can eject this disk. Let's put in OS. I don't know which one. Let's do the latest one. We'll make this one. Oops. Read only, sorry. And we will reboot, I guess. Oh crap, what just happened? Enter cartridge. Protect files. Copy files. Dupe file. Erase files. Protect files. What? Exit to OSA plus. Enter cartridge. What happens if I enter cartridge? Oh, now I'm in here. CP, and I'm back to this. Well, that's really interesting, huh? Ah! Is 267 sectors free a good thing? Alright, so what I'm going to do, I think... I think what I want to do is... How do I get back into this menu? Where I saw that thing. Here, let me do this. Here we go. Copy files. Disk directory. What does this do? Disk directory. File name. What is that? Okay. Oh, how do I see the menu again? Help. Oh, there we go. We figured it out. Protect files, rename files, unprotect, exit to OSA plus. So maybe copy files would actually, like what I want to do is just have what I did with the DOS disk, I put it in. So what I will do, I think, is just like copy. I will copy the OSA disk here. And I will call this, whoops. I'll call this like, I guess we'll call this like roots. And this is the one we'll use with roots. And then I will attach that disk instead. Let me see. Roots, and we'll make this read write. Now I think if I just hard reset the computer, here we go, we're on that disk. Let's enter the cartridge and load up our program. I'll put us back in this mode here. Wow, this is such an adventure, isn't it? Okay. So remind me again, enter or list. We need a mnemonic for this, right? Like, Enter is to load, and list is to save. What's the mnemonic? Enter the loading screen. Could it be enter the loading screen? So I'll remember enter is a loading screen, and lists will save us, because we like making lists of things, to do items. Lists will save us. Enter the loading screen. Maybe we'll see if that works. So now I want to load, so it's enter the loading screen. Enter add numbers dot source. File not found. Right, because it's the wrong disk. God damn it. So what I can do is switch the disks briefly. Right, so we'll switch the disks briefly. Attach disk. Then that was the roots disk here. And then we do enter. Let's see, does this let us load it now? Yes. So now we have it. Now we switch back to our other drive. Other disk, that is. That was in OSA plus roots. I don't know what VRW safe means. Maybe this one, maybe that's what, if I had done this, it wouldn't have had a problem. Anyway, we're just going to do read write because that's what it seems like it should be. And now we will save it here, right? So lists will save us. Look at that. Lists will save us. Great. And then we should also do a bsave. Bsave on this drive. Bsave D. I think I can switch back. Bsave D. Oops, where am I? I'm in the wrong window. Bsave D add numbers dot object file, and then we have to do less than 0600 and what is it, comma, the last number on our assembly screen here. You see it over here, 0609, and that should save that. I think we're good now. And now we go to CP to go back to this. Hey, look, we have OSS. That's so much better, right? All right, so we look here, and now we're in here. We type CP. That will return you to the operating system. Now in response to OSA plus prompt D1. Yes. Oh my God. Is this gonna work? Someone left a comment, I think on YouTube, saying like, oh my God, another chapter just to run it. And like, I was like, yeah, what could be so hard? Look at us. Look at how many problems we have. It's probably just me. You guys probably already have Ataris and you're like, oh my God, this is so easy. But like, I had no idea. How? I'm so close, you know? DOS init do config copy. All right, let's go back to the drawing board. So it was not this. Maybe we have to do max 65 debugger. Yeah, this is where we are, right? Should we read the manual? Yeah, we're using 1.2, right? How do we go back again? Exit. Enter cartridge. Okay, yeah, we're using version 1, 2, which I think is 1.2, funny enough. ASM. Assembler input. DOS exit to DOS. Yeah, this is nothing here about the debugger. Atari's cartridge. Memory usage assembling with offset making. Where? Oh my god, doesn't tell us anything about the debugger. Special notes. Be load by, what by? Exit to the system monitor level. CP, we saw this, right? DOS or CP, either DOS or CP returns you to DOS. If you boot an Atari DOS disk, you'll be returned to a Atari DOS menu. If you put it Atari XL, you will be returned to either a DOS XL or CP. So maybe what's going on is this book thinks we're using the Mac65 disk, and it has the debugger in it. So it's like a separate program, but we don't have that. So what we need to do is how to access debugger from Mac65 cartridge. Maybe came on disk and cartridge. We use the editor and debugger. So maybe this is a good thing too. Glad to show ASM DDT. What is DDT? What the hell is this? Where was that manual? Not this. Not this, right? Machine language is the OSA manual. Mac65 manual. Did I get rid of it? Maybe I got rid of it. Alright, so let's, with Mac65 DDT cartridge. DDT cartridge. Atari. What is that? Dunion's debugging tool. Do you think this could be it? I wish there was a screen of what this is supposed to look like. Does it look like we're doing the right thing? As we've pointed out, that a debugging mode, for example, you can take a look at the memory using the instruction D, which stands for display memory. D. This does not look like... Oh, D600. D600. Oops. Oh, one thing. Whoops. Now I've screwed it up. I can't... D... D600. No, that didn't work. Display memory. The is by typing D. To use, all you have to do is tell the assembler what memory locations you want it to peer into. And you should see a screen display that looks something like 600. No, we don't see anything that looks like 600. Val. So this does look like a debugger, right? But when I type D600, this doesn't do anything. Oh, because I don't have the program loaded, right? I probably reset and didn't load the program. I think. Stop due to program error. Oh my god. Enter cartridge. We're in here. List. List will save us. Enter. What was the thing I said? Lists will save us. Enter. Enter the loading screen? Was that what I said? That's so lame. We need something better than that. But it's definitely enter because I want to load. Enter D colon add numbers dot source. We have it here. Now we've assembled it. That's all we should have to do, right? And now we run. Crap! What did I run? DDT, right? Now I do D600 return. Ah, damn it! D600. D0600. Damn. What is this? You can also use your monitor's D command to look at more than 8 consecutive locations in your computer. Just type the 2 addresses after D. D500, 500F. D5000. Why are we looking at 5000 now? Oh. I think we're using a different debugger. That's what's going on. So we should find out what is DDT debugger. Dunyan's debugging tool, a debugging tool used with Atari macro assembler. Okay, so even though we have this in the cartridge, it doesn't seem like that's what we want to use, right? This player is called, these are the display screens. How do I go to an address? Entering a value. Sorry, hex only. Continue. Go address used to begin execution. Breakpoint, register, deposit, pull. Window. Use the window command chain to filter. Trap, search, flash, warm entry, breakpoint entry. Insert the Atari basic cartridge. Have you can turn off your disk drive. La la la. This looks like it's for basic, no? D your program. Yeah, maybe this is not what we want. Feels like it though, but I'm not really sure how. So let us unfortunately get out of that. And it doesn't look like this thing has anything that is a debugger. What is do? Whoops, do what? It's a com file. I don't know how to use those. This is tough. Okay, so we had this file here, this
What's up,
YouTube
guys?
video.
Today,
I can't hear it because I switched to sound. Okay, so let's see. There, they look like they have like the same kind of thing we have. Loop, right? They're on in like an Atari ST, so it's pretty advanced. DDT. Oh, they're using DDT star 4000. What the heck? Oh my god, we're having problems here. What did it say? It sounded like something was unhappy. So load, enter the loading screen. Enter. And now he ran DDT, brought this, and he did star maybe 600. What did that do? We can see our like sort of stuff there, but it looks like it's empty, right? That's not good. It's all zeros, right? Okay, so oh, he was able to exit this. How did he exit this? Like what command could possibly be exiting this? A, B, C. How do you exit this? How to exit DDT debugger. Launching interactive. Maybe it tells us right away. Compiling. Modifying your job. Launching. This doesn't even look like it's for our thing. This looks like it's for something else, but where is the way you actually exit it? Okay, this is not it. Could this be it? F8? Do you think that could be it? I don't think so. No, that's Altira now doing something. Entering the Max64 file by to return to Max, user can use the command car or menu T. You think that'll work? T car. How do I do this? Use the 0 command. O command? Is that O? Oh! Something happened! Let's wait, which one was it? O? O. That wasn't O. I'm typing O. And I typed 0 before. Crap. How did I do this? O return? O return? Zero, no. 0 return? F8? What was it, F8? I'm like trying, no, it wasn't F8. Because now I'm on the bottom here. Let me get rid of this. Wow, now nothing's working. This is starting, like, I don't think I can release this video because, like, this is not, this is not doing anything, right? But at least I'm learning. It was star 600. And then, I thought it was like O return. Or just O. I typed in OO maybe. 0. No. Like, I did it. How can that be, right? Wow. Overview. I'm like, I can't read this. When you use the 0 command to exit and re-enter, exit DDT. You think there's a way for me to like do a search in here? Exit. Where does it say exit? Exit. Breakpoint, commentary string, hexadecimal. I don't see anything that talks about exit. Window change command. Move display, set program counter. Move display. Start button, select button. Yeah, I'm not really finding the exit. Oh, maybe. Is there a way to like... It thinks there's an exit here. Quit DDT. That's a Q, right? Okay. So we will go back to our gist and type that very important information. So CP, first CP back to DOS. And then we also have DDT, run Dunyan, I think that's what it's called, debugger. debugging tool maybe. And then we have DDT. We have Q. Back to max 65. Oh my god. Okay, so where were we with looking at that video? Because you can say it's all zeros. So what did he do? 5. Yeah, there was this opt. Oh, obj. No, it's opt obj. Opt, not obt. We know this, guys, right? Yeah. Now it's assembled, right? DDT 4000, and there programs there. Okay, so can we, I thought that's what we did. List, and we have opt obj. We assemble it, and now we have D8 on memory location 0600, and then we type DDT. Oh, I didn't write the star command. Star 0600. And we still have question mark, question mark, question mark. Something is wrong, right? I don't know. Maybe we needed to maybe we needed to save this. Doesn't make any sense, right? Zero 0609 list. And then we do DDT again. No, we do ASM. No. It shouldn't matter, right? Do you think it's all those weird REMs I need to have in there? No, that doesn't make any sense, right? Because when I do ASM, we see all of this in the right place. This is just directive, so it doesn't matter. This goes into 600, 608. Yeah, I think this is exactly what the book had. So when we run DDT, we should be able to see that. 0600. Damn it. I have no idea. Yeah. Oops. What'd I just do? We don't know how any of this works, really. I guess we can try to do this like star 600 to, whoops, star 0600 comma, no, star 0600 space, no. There's also an L command, max 65. I guess what we should really do is find this max 65 debugger. Just getting tired now. This cartridge at hand. Do you think maybe I needed to load an older max 65? disk. Why don't we try that? So we'll just switch drives here to like maybe, oh yeah, we're 1.2, right? One 1.2 now. I don't see anything in here that has the debugger though. Directory, rename old, erase, protect, unprotect, load, save, run, hex adder, cartridge. Easy MD, but I don't think so. We're getting good at this, right? Oh, that's the other disk. Maybe we can save, maybe we can use, does this one have it? Or did I overwrite it? Is this the one that I have the wrong stuff? Yeah, we do have it here. So now we can do ASM. We have the code here. So I think DOS is loaded in memory, right? So now maybe I have, what was it called? CP. I'm still in DOS 1.2 and it says I should be able to run debug. That's what it said, right? In the very beginning, you type CP, then you type bug65. Nope. We're getting desperate. Bug65 program. So there is a program. RAM loaded machine language program. Yeah, so display memory. Address parameters. Bug65 is shipped on your master diskette as a relocatable command file. Bug65 functions just does any OSA plus extrinsic command. Simply type bug65 when. Alright, so we just need to find bug65. I hope this isn't right. Atari roots. Uh-oh. I want to use the disk versions. No matter how I approach it, I've attached the latest disk that I'm using with test program Atari Utes, Atari roots assembly, da 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 da. Yes, one, forget bug65. DDT is far superior. My goal is to do everything with disk images. Extended DDT runs from disk. Shift escape escape set for bringing up task manager. So, all right, that sounds like a good thing to remember. So maybe well, the whole point was sort of using bug 65 though. I'm going through Atari roots. Here, ATR from this page. It sounds like they don't trust this, but maybe we just download it directly. We have a disk now, and we put this disk into our Atari folder. Mac 65. Now let's load that into our drive. Let's actually copy this so we have a copy. And then we'll do a hard reset. All right. Files on disk. Whoa, what are we looking at? So here we are on Mac 65. So let me get rid of the cartridge. Detach cartridge. So what is that all saying here? Welcome, duplicate this disk. I don't know what any of that said. Go to address, save binary files on disk. We have Mac 65. And we saw bug 65. You guys saw that? You saw bug 65 here. So that's pretty interesting. So now how do we load a file? How do I boot something? It's because 2 cartridges isn't gonna get me anything, right? Uh-oh. There we go. DOS. Load binary maybe? File to load. Mac 65. Alright, maybe what we have to do is mac65.com. So maybe we need to load mac65.com. That does not look right, everyone. So it's not load binary, protect files, go to address, extended command, initialize disk, erase files, copy files, files on disk, quit to DOS. Let's go to DOS. Now we type Mac 65. Alright, something is wrong here, for sure. Could it be the kind of system we're running? Atari XL computer system memory. Wait, why do we have so much memory? Why do I have Rambo? Let's do Atari 64K. I don't know why we have all of this in here. Alright, so let's try this again with a hard reboot. And then we do Mac 65. So maybe Well, okay, let's do this then. Let's see if bug 65 works. No. Tried this and it works fine. So everything I've tried works well, but I can't figure out how to exit. Well, why did this work for this person and not me? Let's so I really can't go here. I can't go to this website. Here's an ATR of Max 65 with bug 65 2.0 on DOS XL disk. Maybe we don't need a DOS XL disk. Let's keep looking to see where else we can find bug 65. I assume there's no cartridge of this, right? Image, bug 65 version 2. Oh, look at all of these. This is the DOS XL. Max 65 with bug XL. Normal patch 4 but with 3000 color. Normal relocatable further with already patch version 4. Alright, so maybe this one is different. I mean, it's possible, right? This is a different ATR. Let's just try to change this. We'll just go directly and try this one. Atari. Now we have bug 65. And we have max 65. Alright, that doesn't look... It looks like it's the same problem, right? What is the difference between 200 and... It's like there's some kind of like weird display problem. Atari 800 XL load funny characters. Scrambled screen, that's a good thing. Yeah, it looks a little bit like this. Yeah, this is not scramble screen Altera. Sure feels like it's some kind of configuration problem. Is it my ROM maybe? Let's disable basic. How do we do that? Didn't we have something basic? Oh. Boot without options pressed. Alright, so let's do that. And we'll just reload here. Guys. Oh my god. Oh my god, I'm gonna cry. So, we go back to our gist here. And we edit. And we write down general. Okay, where do we get this? Max 65. DDT. How should I even say this? Here, I'll just put it in general. Do not enable basic loading without by default. And this is in Altira's, where was it? It was like under configure system firmware. See Altira's configure system firmware. Enable basic. Make sure this is off. That's one thing. The other thing is get debug 65 from, and what was the page that we got that from? This one probably would have worked, right? But I like that other page we found. This one, right? No. Yeah, this one. All right. I think that was that, right? Supposedly better debugger than debug 65, but isn't explained in Atari roots. Is that fair? All right, so let us try this again. I am going to just like, oops. Where am I here? Not this one. It's not this one. Just one sec. All right, here we go. I'm just going to copy this drive again. Did I already do this? Is this the one we're using? No, we're using the one in downloads. So I just made a copy of it. I guess I'll also move the copy to the Atari thing. So now we have this, right? This is the copy. All right. So from here, I'm guessing I can just run max 65. I don't know the difference between 420 and 200, but let's run 420. Bigger numbers better. Whoa, it looks totally different now, right? This looks like the evil version, the dark mode version of max 65. So we don't have our program here, so we're gonna have to load it. We're gonna have to switch to the other disk for a second. And that disk was in Atari, under Atari. Here, I'll switch to desktop mode. It's under Atari roots. And then enter the loading screen. Let's hope that this still works. Hey, look, it works. And now we can assemble this. And it looks like it was happy with it. Now we go back to the drives and we switch this to the one we downloaded. I'll just leave it under safe and see how this goes. Alright, so now what should happen is I should be able to type CP. And now I can type debug 65. Wait, what? Are you kidding me? Oh, bug 65. I just freaked out. Oh god. We're afraid, right? Display. Guys, it did it. Holy cow. All right. D600, and that's what we typed, right? D600, same thing as 0600. Right. So you should see something that looks like D818A902690285CB, and then if you have a Max 65 assembled, there'll be a few extra characters after the letter CB. Don't pay attention to them. They're printed forms of the characters that could be represented by the numbers in this line. Okay, so we don't have to worry about it. I had no idea that it would take this long to kind of figure out how to get here. Holy crap. I'm just sort of like in awe, like this is not easy, right? Like you guys, like I noticed like half you guys that watch this stuff, you already know this. Like you already know all of this stuff. I don't know why you're watching it. I think it's like, haha, look, you're falling into the traps. Um, but for me, I just feel like, wow, this is hard. Not because the language itself is hard. It's just like we're trying to recreate like what worked before, you know, like instructions from before, but like this book doesn't know what cartridge I had or whatever, so it just didn't work. I can imagine people getting the cartridge from Max 65 and trying to follow its instructions and it wouldn't work. Anyway, so I guess what this means is we'll kind of see, maybe we'll switch to DDT later, but for now I guess maybe we'll use this version of Max 65 assembler. Um, so I'll make a little note that I should update the Mac65 assembler link. I love writing with pencil. Update Mac65 link. All right. So, where are we? The rest of that line, as you can see by glancing at one of the object code listings we've created in the other exercises, is nothing but a stripped down machine code listing of the first 8 bytes of your add numbers object program. You can also use your monitor's D command to look at more than 8 consecutive locations in your computer's memory. Just type 2 addresses after the D using the format. So we will do D 5000, comma 5000F, 500F. I think they wrote it wrong. It should be no. I'm not really sure what's supposed to be in 5000 and 500F. But I guess like maybe that was just an example. Oh, look at this. If you have, oh, this if is for here. I assumed if you have this and then this, but that's not what it meant. So that means that I should type in a space, 5005F. There we go. All right, that's just confusing. But that's not our program. So we do ours 0609 because I want that extra one. All right, so this is our code. That's great. And it should look a little bit like this here. 690285CB6000. It's perfect. We're back on track. Like we're literally back on track. We're okay now. It just took forever to get here. An hour and a half to get here. And we haven't even run the program. That, of course, is a disassembled listing of your complete addition program all the way down to its last mnemonic, the RTS instruction. Atari Assembler's Editor's L command. Okay, so there's an L command, but this is for Atari Assembler, which we're not using. It says the Mac65 also has an L command, but it's entirely different. The Mac65 L command is used for locating hexadecimal string, but the Atari Assembler's L command can be used to display disassembled listings of machine language programs. The Atari Assembler's L command is similar to the D command, but there are some differences. The L command, like the D command, can be used with either 1 or 2 addresses. When you use one address, L will list the contents of 20 consecutive memory locations in your computer, not just the contents of 8 locations as the D command does. So, well, I'll just read. Whether you use that optional second address or not, L will disassemble the machine code at the addresses it lists alongside each hex number listed. It will also list the assembly language instruction that the number equates to, if any. To get a look at how the Atari L command works, type the following on an Atari assembler. This. Oh, that's really cool. It goes back. So it takes this stuff and it brings back the assembly language code. That's really cool. By merely looking at this listing, you can see that your program has been assembled and loaded into RAM correctly and now just sitting in RAM and waiting to run. Perfect. Now we've come to a debugging command that can actually be used to run a program. The G for go or execute. That's so awesome. Guys, we're here. We're here. Let's just read. Let's just read a little bit more. Golly gee. Fortunately, the G command can be used on both the Mac65 assembler and the Atari assembler editor cartridge. By using the G command, you can instruct your computer. I've never been so excited to add two numbers. Like seriously. By using the G command, you can instruct your computer to execute machine language code that begins at any specified memory location. If you have the Atari assembler editor cartridge, it's very easy to use the G command. While your assembler is in its debug mode, just type the letter G immediately followed by the memory address at which the program or routine starts. Your computer will then run the program or routine that starts at the specified address. If you're using an Atari assembler editor, you can use the G command to run your add numbers program right now. All right. So that's for the easy. That's the easy mode. What? It feels like we chose the wrong assembler. If you have a Mac 65 assembler, the G command is a little more powerful. Oh, I see. It's more powerful, and in this case requires an additional parameter. When you use the Mac's G command, you can, and in this instance you should, use both an initial address and a termination or breakpoint address for the routine you want to run. And when you type your program's breakpoint parameter, you must flag it with the prefix at. For example, here's how to use the G command to execute the add numbers program using the Mac65 debugger. G's 0600 at 0608. 0608 is the last instruction in our program, the memory address with the last instruction. A number of other ways in which the G command can be used are listed in the Mac65 and Bug65 User's Manual. Alright, so do we just run it? I think so. G0600 at 0608. Cross our fingers. User run break. Guys, the accumulator has a 4 in it. But remember, we stored the value with in memory location like CB or something like that. So we have to check that too. But this is cool. We have a 4. If your add numbers program runs without any hitches using the G command, you won't see much action on your computer screen. The computer will quietly do its job, which is adding 2 and 2, and then quick as a wink, it will return control of your computer to you. At that point, what you'll see on the screen is a display of your Atari's internal registers. If you have an Atari, your screen assembler, it'll look like this. If you have a Mac 65, it'll look like this. Both of the above displays have the same general function. Both tell us that your program has finished running and has left some values in 5 of the 6502 status registers: the accumulator, the X, the Y register, and the process status register, and the stack pointer, which is program counter, I believe. The line displayed by the Mac65 debugger also lists, the address that was in your computer's program counter PC when the program reached its breakpoint. The last item in the line tells what the instruction at that address was, RTS. Yeah, we have RTS on our screen too. That's pretty cool. All of this information can be useful in some debugging applications, since it's sometimes helpful to know what condition the 6502 chip has been left in after a program has been run, but doesn't mean a great deal to us right now since our addition program has finished running and we don't really care what the 6502 registers now contain. What's more important to us at this moment is whether or not our program did the job it was supposed to do. The only way we can find that out is to look and see whether the program did what we instructed it to do, namely whether it added 2 plus 2 and stored the result of that calculation in memory address CB. While your assembler is in debug mode, you can easily peek inside of memory address CB and see if the sum of 2 and 2 is stored there. Simply type DCB. So 00CB must be the address, and then here's 4. Yeah, so this is what. You should see 1 or 2 lines, something looks like these on your video screen. CB04, right. I think that's the important part. Success, the number 4, the sum of 2 and 2 is indeed stored in memory address CB. All right, so what I want to just do here is bring up the browser and just like write some of this down real quick. And that was in the debug 65, which we did not make a thing for. Probably this should be down right later, right? DCB display memory address CB. And then we also had like what was the other thing to G, right? It was like G0600, and then was it a comma or a space? I think it's a space at 0608. Run program in memory 0600 breakpoint at 0608. All right, and then display, we had a display, right, where no, we don't use the L, but we have this D0600. So that's the same thing as CB, display memory 0600. But actually, I'll just, because we already have CB, it's the same thing. But in here, we can do 06098 display memory for this range. Okay, of this range. Oh, you get it. All right, so we've done that. And we have run the program. We got the address. It had the right results. We saw all of this. Saving a machine language program. How much more is there to this chapter? Oh my God. That was page 89, and we are still on 83. You think we can do it? Nah, I think we're like at 1 hour and 40 minutes. So we're gonna stop here. This was really cool. We ran the program. So there's that much, right? I can't believe the next video is gonna be like, after we run the program, like what's the other ways of running the program? And this is like 1 hour and 40 minutes in. Unbelievable. Well, I sort of apologize for getting so sidetracked there, or lost really. Of course, I didn't do it on purpose. But this concept here is learning with me is really just like, I'm learning this too. I did a video on Haskell, which I sort of knew already, right? But I made it a learning with me because I don't know it that well. But I went through it and someone said like, oh, this was a little too fast. And I was like, oh, probably because I know it. Like I'm not, but this is obviously not too fast, right? We might be lost now a little bit, but I think we got through it. Just used the new Mac65 assembler image and used a new, that has the debug 65 also. I think that's really the main thing to do, right? And then you're golden. You're all set. So if this was interesting, please do like and subscribe. I have a Discord server where you can tell me what you thought of this video and how it can be better, or ask any questions like, hey, I didn't follow that part. I'm really happy. Like, no one's asked a single question. Be the first, and maybe you get a prize. Ask, like, where's my prize? And then I will get you a little prize. If you're the first person, and it has to be in a public channel so we see it. All right, I think that's it. We will continue again soon. I hope you enjoyed it. Thank you. Bye.